సార్ అండ్ సార్ వచ్చారు సార్ వెరీ గుడ్ థ్యాంక్ యూ. వస్తానండి.
వచ్చినాడు.
సార్ నమస్తే.
నమస్తే రాజు గారు.
నమస్తే సార్. గుడ్ మార్నింగ్.
వెరీ గుడ్ మార్నింగ్. స్టార్ట్ చేశారా?
స్టార్ట్ చేస్తాం సార్.
ఏం బా
స్టార్ట్ చేస్తాం సార్.
చేయండి, స్టార్ట్ చేయండి.
Good morning, everybody. I warmly welcome to external expert Professor Dhananjay Rao Garu, Professor Department of Geology, Andhra University, Visakhapatnam, and also welcome our beloved principal and Dean Faculty of Sciences, Professor K. Krishnanandi Garu, Jilledubanderu University, Kadapa, and also my colleagues, Dr. Raghubabu, Dr. Sunita, Dr. Jay Raju, and Srinivas Gowad, and also academic consultants, students, and also print electronic media. On the occasion of Ph.D. Vaivavasya of Mr. Rasekar, who is doing Ph.D. under my guidance. Previously, he did the MSc in the Department of Geology. In that, he is a regular hard worker and also dedicated in nature. After that, he joined PhD under my guidance. Though he is a RGNF fellow. After that, he has got a senior research fellowship. Then he has published a number of publications both in national and also international, both in Springer as well as in elsewhere. Now I request Rasekar come over the dais and explain briefly about that your work on mainly introduction, methodology, conclusions, and also results, and also give the answers raised the Adjad gets questions. Thank you, sir. Thank you. One all. Now I request Rasekar. Start.
Good morning to one and all. Today my PhD Vice presentation entitled by Watershed Development for Sustainable Growth of Jilledubanderu River Basin, Anantapur District, Andhra Pradesh, using geospatial technologies under the guidance of Dr. G. Sudarshan Raju, Associate Professor, Department of Geology, Yoga University. Okay, nowadays groundwater resources are declining due to the escalating of population and also growth of urbanization, and and also the urban industrialization also increasing. So for that, we have limited resources and we have more demand. Okay, for that, I've taken the watershed development of river basin for sustainable development. Okay, watershed is defined as It is a geological unit of an area draining to a common outlet point. Watershed development refers to management and regeneration and judicious use of all the resources such as natural resources like land, water, plants, and animals within the watershed area. And watershed development basically involves the harmonizing the use of natural resources between upstream and downstreams of the downstream reaches towards the objective of natural resource conservation and increased agriculture productivity and better standard for living inhabitants. Watershed development need for proper planning and management. Integrate watershed development approach also it includes through using some recent advances in watershed, like use of computer models like remote sensing and GIS. Okay, the present scenario of India, that is India has 2% of oral land and 4% of water and 16% of population and 10% of water. Coming to geographic area, there is a 329 million hectares in which 47% is cultivated and 23% is forested and 7% is non-agricultural and 23% is wasteland. Okay, as per capita availability of land 50 years ago is 0.9 hectares. It could be reached 0.14 hectares in 2050 due to the increasing of population. Okay, coming to out of cultivated area, 30% is irrigated, which produces 55% of food, and 63% is rainfall, producing 45% of food. So we have limited resources, more demand. We have more demand. Okay, for that I selected Jilledubanderu River Basin is my PhD topic. Jilledubanderu River Basin chosen as a research area response to increase the demands competition among the major water using sectors such as agriculture, drinking, and industries. The growing concerns over how these demands can be efficiently, equability, and sustainability met. The increasing concerns over water pollution from agriculture, drinking, and industrial users. The innovative water management and allocation policies to promote the economic development of village community of the river basin. Okay, significance of the study. Conjugate use of surface and groundwater, which can be increased efficiently, reliability, and cost effectiveness of water use. Enhance the agriculture growth in the irrigated agriculture production. The facilitate efficient intersectoral allocation of water, including transfers of water out of the agriculture. The reverse ongoing degradation of the water resource base, including the watershed area and irrigated land base and water quality. So this is based upon the study. I framed a different objectives. First objective to assess the surface and subsurface characteristics to morphometric studies of the river basin, to understand the vegetational changes indices detection through Google Earth Engine of the river basin, to assess the rainfall runoff for watershed, the management, planning, and suitability for construction of groundwater resource surplus. And also, fourth objective to understand the groundwater quality of river basin for suitability analysis in drinking and irrigation purpose. To carry out the geophysical investigation to delineate the groundwater potential zone, and finally, to recommend the various watershed programs based on the present sustainable growth. So this is my chapter readings. My chapter readings: introduction, environmental setting of the area, morphometric analysis, hydrological modeling and watershed analysis, groundwater chemistry, groundwater exploration through geophysical studies, and watershed development for sustainable growth, and summary and conclusion. Okay, chapter 1 covers the prologue and research problem need for watershed development programs in the study area, research work, aims and objectives, the study areas, the scope of work, organizing purposes. Second chapter includes the environmental setting of the area. Again, this chapter subdivided to 50,000. The majorly my study area covers the Bukkapatnam, Dharmavaram, Mudiguppa, Nalamada, Puttaparthi mandals of Anantapur district. The majorly my study area covers the Bukkapatnam and Mudiguppa mandals of the Anantapur district. Okay, coming to natural environmental factors, geomorphology. Geomorphology is classified into 5 categories of my river basin. In my river basin, majorly occupying the denudation, large and pediment complex around 54%. And coming to next category, the denudation origin and moderated discadations around 36.85%. Coming to water bodies, there is a 4.18% is there. So we have the limited resources in the river basin. Okay, coming to geology, geology is categorized into 4 categories. And firstly, the Hanban bitrate is bitrate gneiss is around 57.87% is forming, and after that, granites and granodiorites 20.59 percentage, and grey granite and green granite 21.10. One small patch of Lamprey is situated in the mouth of the river basin, only 0.44%. Coming to lineament analysis, for lineament analysis, I taken the 3 types of DEM data like Ashtar DEM and SRDM data and Watershed DEM. Okay, based upon this DEM data, I received the best result in the Watershed DEM data. It is easily available in our Indian territory by the website One NRSC. This is a slope map. Slope map also categorized into 4 categories. In between the 0.5 degrees, 5 to 15 degrees, and 15 to 35 degrees, greater than 35 degrees. The majorly my river basin falls on the in the gentle slope in between 0 to 5 degrees is 49.61%. Coming to soils, okay, based upon the hydrological characteristics, my river basin is classified to 2 types of hydrological soil groups. Soils like hydrological soil group B and C. Hydrological soil group covers around 58.40%, and hydrological soil group covers the 41.60% in the river basin. Coming to climate and rainfall, my river basin records the climate in the summer season around 40 to 45 degrees. In winter season, 20 to 25 degrees records it. And coming to rainfall, I collected the rainfall from 1995 to 2020 through collectorate office in Anantapur district. Okay, we can see in 2001, 1998 and 2001 and 2005 and 2015, we received the more rainfall in the Anantapur, my river basin. And coming to average monthly rainfall, the rainfall records in between June to October is June to September only. Why? Because these months only recording means this is the monsoon period, so we receive the more rainfall in these 4 months only. Other 8 months we receive a little bit rainfall also. Coming to this is the spatial distribution of rainfall map of the my river basin. The central part of the river basin receives the highest rainfall compared with other regions of the river basin. Okay, this is the land map of my study area. Okay, I categorize 6 categories. Mainly agriculture cropland around 38.01% is covers, and coming to next category forest land around 32.46% is there. This is a socio-economic profile of my study area. The population density, based upon the population density, I taken this map. This is the cropping pattern, different cropping patterns of my river basin. Okay, in some this area, intercropping like groundnut and red gram is growing. In some this area, some red grams also growing. Some mango cultivation also growing. Some in the river banks like river bank sites, paddy cultivation also undergoing. So this is the entire methodology I adapted for my PhD thesis. So this is the entire methodology. First objective, that is morphometric analysis. In the morphometric analysis, I went for the linear and aerial and relief aspects. And coming to second objective, the rainfall runoff modeling. After getting rainfall runoff modeling, if excess runoff is there, there means I went for the rainwater harvesting structures. And if deficient of runoff is there, means I went for the groundwater research structure. Simultaneously, I went for the groundwater potential zones also, mapping up groundwater potential maps also using remote sensing and GIS. And after that, I went through the vegetation and drought modeling. In that, I categorized different type of droughts like hydrological drought, and metrological drought, and agricultural drought also. And nextly, I went for groundwater chemistry. I collected the 2 season samples, pre-monsoon, post-monsoon in the year of 2019. After that, I went for the groundwater suitable analysis for drinking and irrigation purpose. And finally, I went for the geophysical investigation to explore the groundwater. Okay, by combining these all objectives, finally I went for the watershed development plan through land suitability analysis for the sustainable agriculture. This is coming from morphometric methodology, morphometric objective. So this is the computation various parameters I taken through morphometric analysis through SRTM DEM data. This is the 14 parameters I calculated. This is the formulas I used for the calculation of these parameters. By these are the references I used for the morphometric analysis. This is the data I used topo sheets with through Survey of India, Dehradun, and Landsat satellite imagery. This is the Earth Explorer. USGS I taken Landsat 8, and SRTM also I taken from the Earth Explorer. This is the entire flowchart explaining the how to extract of the DEM data and what are the different aspects of morphometry. So after downloading the SRTM data, I went for the DEM processing in the ArcGIS. This is the tools I used: fill and flow direction, flow accumulation, and stream order, and stream watershed grid, and finally I converted vectorization as a shapefile. After shapefile conversion, I went for the stream verification through Landsat 8 satellite imagery of the river basin. And after the stream verification is completed, I went for the morphometric analysis. And morphometric analysis also categorized into three types. That is linear aspects and aerial aspects and relative aspects. In the linear aspects, I went for the stream order, stream number, stream length ratio, bifurcation ratio, and mean bifurcation ratio. In aerial aspects, drainage density, drainage structure, stream frequency, circulate ratio, length ratio, drainage structure. Coming to relief aspects, I went to basin, calculate basin relief and relief ratio and slope map of the study area. So, this is the drainage, the entire drainage map of the my river basin. I got the highest 6th order stream of the my river basin. This is the linear characteristics of the river basin. These are the linear features, linear aspects. I got the total number of streams of the my river basin is equal to 1410. And this is the bifurcation ratio values, and total length of the streams around 956.31 kilometers. So these are the aerial characteristics of the river basin. This is perimeter length, the perimeter around 143.38 kilometers and length 37.45 and form factor 0.347. These are the various aerial aspects of the my river basin. This is the relief aspects. So I got the relief ratio around 0.24. This is the drainage density of the my map. This is the aspect map, and this is the slope map of the my river basin. Coming to next objective, hydrological modeling and watershed analysis. For that, for first one, I went for the rainfall runoff modeling. This is the flowchart I used for the calculation of rainfall modeling. Okay, first I went for the data collection through satellite imageries, and also I went for the field-based data. Okay, in satellite imagery, I went for the Landsat 8 and SRTM data. From Landsat and SRTM data, I prepared the LULC map and slope map. From the field-based data, I taken the existing structures like check dams, bottom ponds, and percolation tanks in the field-based study. And also I taken the water levels data, and from the water levels data, I prepared the water zone, and also based upon the soil textures, and also I prepared the soil map. Okay, after that, LULC map and soil map by intersect option in the ArcGIS with curve number and precipitation data, I got the rainfall potential map. This is the rainfall potential map. I got the my river basin. I got the moderate and a high rainfall in the major portions of the my river basin. This is the area and percentage area of the my river rainfall runoff. Okay, majorly my study area covers the moderate rainfall runoff around 48.52%, and coming to high also 18.86. Okay, based upon the runoff nature, I went for the proposed for the rainwater harvesting structure based upon this flowchart. Okay, up to when I got the rainfall potential map, before slide I explained this whole thing. And when I got the rainfall potential map, okay, some integrated mission for sustainable specifications are there. Okay, based upon that specifications, I prepared the potential rainwater harvesting site zones. After getting the potential rainwater harvesting sites, I went for the rainwater structures for research. Like based upon the existing structures, I proposed the various research structures. Okay, this is the sustainable specifications for the adoption of rainwater harvesting structures. This is the map of our rainwater harvesting structure. Okay, based upon the previous map, based upon this map, I went for the proposed structures like check dams, farm ponds, and population set. I proposed around 48 structures in the river basin based upon the existing structure data. Okay, after that I went for the groundwater potential zones. This is the flowchart I followed for the groundwater potential zones. I taken the various data like topographic maps and remote sensing data and conventional maps and collateral data. Through topographical maps like topo sheets, I extract the drainage, and through drainage I calculated the drainage density. Through remote sensing data like Landsat and SRTM, I went for the geomorphology, slope, and land use land cover. And when I went for the conventional map like through GSA and NBSS, like National Bureau of Soil Standards and Land Use Planning located in Nagpur. Through two organizations, I prepare with the help of two organizations, I prepared the geology and soil map, and also I collected the water level fluctuations through Groundwater Department of Anantapur, like pre-monsoon and post-monsoon. Based upon the pre-monsoon and post-monsoon water level fluctuations, I prepared the water zone. Okay, I taken the 8 thematic maps for the calculation mapping of groundwater potentials like drainage density, geomorphology, slope, LELC, geology, soils, and water zone. Okay, after 8 thematic maps, again I went for the raster conversions of all thematic maps. After that, I went for the weightage assignment. This weightage assignment, I went for the various decision making models is there like AHP, Geology, frequency ratio. There are a different decision making model is there. For that, I taken the 2 decision making models like Geology and AHP. Based upon the, I assigned the different weights for this thematic layers like subparameters. And after that, I integrated this 2 AHP and Geology. I integrated third method. I proposed the third method like fuzzy AHP, integrated fuzzy AHP method. Based upon these 3 decision making models, I got the groundwater potential zone map in ArcGIS. These results I validated with the groundwater levels of the study area with machine learning program. But this is the 8 thematic layers. This is the percentage of the area occupied. This is the subparameters of the various thematic layers. This is the AHP weights I assigned like this, and this is the fuzzy weight assignments I assigned in the ArcGIS chapter. Okay, based upon this is the 8 thematic maps I prepared in the ArcGIS. Okay, based upon the overlay option, I got these are the result. But compared with AHP Geology, I got the better result in the integrated fuzzy AHP. With validation also, I got the better result with Geology integrated fuzzy AHP. These are the third map is the fuzzy integrated fuzzy AHP maps, which is around 82% matching with well data. After that, I went if deficient of runoff is there in that area, I went for the groundwater artificial research structures. Based upon the previously I explained some thematic maps. In that, I taken the other thematic layers like rainfall and lineament density. I taken other than before thematic map. And same thing. I went for the raster conversion. But here I used another decision making models with combining Geology, AHP, and also I used another decision making model like frequency ratio method. Again, I combined these 3 into integrated by 3 methods. I got the 4th method also integrated fuzzy AHP and frequency ratio method. And after that, I got the overlay. I went for the overlay option comparison, and I got the results, and I validated with the well data. This is the various thematic layers I taken before slide I explained. This is the subparameters, the subclasses. This is the AHP weights, and this is the Geology weights, and this is the frequency ratio rates. But this is the 8 thematic layers I taken. This below I indicated. This is the results I got in AHP and Geology and frequency ratio and integrated approach. By combining these 3 AHP, Geology, and frequency ratio, I got the integrated approach method. This is the better result I got in the artificial research. Okay, this is the result I got in the integrated approach. Compared with the other than integrated approach is better. Before integrated frequency ratio also getting good results. Okay, after next in hydrological modeling, I went for the vegetation drought modeling. In that drought modeling, I calculated the how much area drought area. But this is the flow chart I taken for the various drought identification. Metrological, I taken the meteorological data like monthly rainfall. From monthly rainfall, I calculated the standard precipitation index. Through standard precipitation index, I estimated the meteorological drought. And also I taken the satellite imagery like MODIS data. It is 250-meter resolution. And I taken the basin map. Okay, from MODIS image, I taken the NDY. Through NDY, I prepared the vegetation condition index of that river basin. Okay, based upon the VCI and NDY, I identified the agricultural drought. And also I went for the field data like groundwater levels. Through groundwater levels, I calculated the standard water level index. Through standard water level index, I identified the hydrological drought. Okay, this is the NDY data I taken from 12th July to 30th September in between from 2001 to 2020. Why I taken? Because this month only irrigation will be starting, monsoon also starting. So all people are ready to irrigating in that my river basin. So this is the through NDY I take from MODIS image I calculated the NDY. NDY is normal difference vegetation index. Through vegetation index again I calculated vegetation condition index VCI from 2001 to 2020. See here the red places showing that severe drought locations, and yellow will be shows the moderate, and green color is no drought. We can see here in 2001 and 2015 and 2010 we are facing a severe drought in the Anantapur district. Okay, through this is the meteorological drought through monthly rainfall. Based upon the monthly rainfall, I prepared the meteorological drought graphs. Through this is I done with R programming. Okay, this is the standard references I taken for calculation of meteorological drought and hydrological drought. This is the hydrological drought. I taken the water levels from pre-monsoon and post-monsoon from 2001 to 2020. These are the areas we are getting more drought in the regions. Okay, finally I went for the groundwater chemistry. In groundwater chemistry, I taken the suitable analysis for drinking and irrigation purpose. So I taken the sampling season in the month and year. The pre-monsoon in April 2019 and the post-monsoon December 2009. Okay, this is the sampling locations I taken in around 48 locations in pre-monsoon and 48 locations in pre-monsoon. Okay, this is the laboratory and instrumental methodology to calculate the various parameters in groundwater. So these are the various instrumental and analytical methods I use. These are the agriculture suitable index. I calculated the sodium absorption ratio, Kelly's ratio, soluble sodium percentage, residual carbonate, permeability index, salinity, magnesium azote, and Piper diagram. Based upon the Piper diagram and Gibbs and Wilcox and Sir, I calculated the suitable analysis. So based upon the physical chemical analysis, through total hardness, my samples are very hot in pre-monsoon around 95% and post-monsoon around 4.35%. This is the analysis parameters in pre-monsoon. These are the post-monsoon. Okay, this is the minimum value of the various parameters in pre-monsoon, and this is the post-monsoon values. Okay, this is the Piper diagram. The Piper diagram shows it is evident that the groundwater is mainly constructed of calcium and magnesium bicarbonates. The calcium and magnesium imparts hardness to the rock and pond due to weathering process, which lead to dissolution of minerals from parent rock. And bicarbonates, on the other hand, are dominant due to the weathering of carbonates and dissolution of silicate minerals. The higher values also indicated the anthropogenic activities. According to the Piper, there is not much dominance of sodium, chloride, sulfate in the groundwater samples. Okay, these are the suitability of groundwater irrigation. These are the parameters I taken in pre-monsoon and post-monsoon. These are the maximum and minimum values of my river basin. Okay, this is the suitable analysis of the irrigation. Coming to these are the parameters. These are the suitability analysis I taken. Coming to percentage of sodium, all samples are in pre-monsoon and post-monsoon are suitable for irrigation. Coming to share also, all samples are better for irrigation in pre-monsoon and post-monsoon. In PA also. In permeability, coming to permeability index, pre-monsoon, the 94% samples are not suitable, and here 48% of samples are suitable and 42% is not suitable. Coming to RSC, all samples are suitable, and Kelly's ratio also, all samples are suitable in pre-monsoon and post-monsoon. Coming to magnesium hazard, only in pre-monsoon 56% is suitable, and post-monsoon 33% is suitable. In coming to sodium soluble percentage, around 96% of samples are suitable in pre-monsoon and 88% of samples in post-monsoon. This is the calcium and calcium alkaline. This is the salinity diagram of pre-monsoon and post-monsoon. This is the Wilcox diagram pre-monsoon and post-monsoon. Okay, based upon the Wilcox, there are 56% samples were good to permissible limit, and 8% of samples are unsuitable, and 36% are doubtful to unsuitable in pre-monsoon. Coming to post-monsoon, 23% of samples are excellent, and 58% are good permissible limit, and 4 samples are unsuitable, and 15% are doubtful to unsuitable in post-monsoon. Okay, this is the Gibbs diagram pre-monsoon. This is the post-monsoon. Based upon the Gibbs, it is the evident that all samples fall between the rock dominance zone and evaporation dominance zone. In the general slope, in the region is very low. There is an increasing residence time of groundwater. The results shows the high rock water interaction. As the groundwater is from semi-arid climatic region, the evaporation is dominance is obvious. So this is the groundwater quality index I calculated for this drinking purpose. This is the water quality index. Based upon the water quality index, based upon the water quality values, the water quality index is categorized very poor. From in between, we will get the value 200 to 300. The water is very poor, and 100 to 200 means poor, and good means 50 to 100, and excellent means less than or equal to 50. Out of the total 96 samples, like pre-monsoon and post-monsoon, in pre-monsoon 3 found good and 26 are poor, and 16 samples are very poor and 3 are unsuitable. Coming to post-monsoon, 25 samples are found good and 19 got very poor and 4 are very poor quality. Hence, it is in fact that 94% of samples are found unfit in the drinking in pre-monsoon. In coming to 48% of water samples found suitable in not suitable for post-monsoon. This is the spatial distribution map by the physicochemical properties of my river basin. This is from pre-monsoon and post-monsoon, from pH to nitrates. Finally, I went for the geophysical investigations for investigation the groundwater exploration. So I went for the field-based study in this entire river basin. So I taken the various VS points in my river basin. I went for the field base, and also I taken the 6 VS cross sections from A to B and K to L, and this all sampling overlaid in the land map. Okay, based upon the geophysical resistivity data, I calculated these are the parameters like electrical anisotropy, transverse resistivity, longitudinal resistivity, transverse resistance, and longitudinal conductance, aquifer resistivity, and aquifer thickness. Okay, based upon the geophysical parameters and with including remote sensing data, I went for the groundwater exploration like groundwater potential zoning mapping. Through remote sensing data, I taken the various thematic layers like slope, LULC, and sediment density, like conventional maps, soils, and geology. Geophysical studies like geophysical parameters like I taken the aquifer resistivity, aquifer thickness, transverse resistance, and anisotropy, and linear conductance, and collected through collected data like water zone, water levels data. I prepared the water zone, and rainfall data also I collected through collectorate in Anantapur. Okay, based upon these various thematic layers, I went for the decision making models like AHP and fuzzy, and after that I went for the weighted overlay analysis, and finally I got the groundwater potential. Okay, for validation I have taken the groundwater fluctuation data using AUC and ROC curves. So AUC is nothing but a area under curve, and ROC is receiver operation curve. Okay, this AUC curves are drawn with machine learning programming. Okay, this is the VS curves of my river basin of entire river basin. Okay, this is the curves, but I got this type of curves around 39 curves are around 40 AA curves, and later next HAK and AA7, and least I got only one H. This is the parameters I take. This is the thematic layers I taken for the identification of the groundwater potential zones. Okay, this is the cross sections values, pseudo cross section values I drawn with. These are the from A to B, C to D, and cross section E and F. So here we can see in this layer we are getting good amount of water by geophysical study we can analyze, and here also we are getting good amount of water, and here also in this cross section IMG. This is the VS points I taken in that regions. Finally, I got this is the groundwater potential zone map by overlaying by using decision making models like AHP and Fuzzy. I got the this is the groundwater potential zone map of the study area, and laterly I used the AS and ROC curve. This is the map. It's around matching around 82%. It is a very good accuracy with water level fluctuation data also. Okay, finally, final objective I went for the watershed development for sustainable growth. For that, I went for the preparation of groundwater research plan, and also I went for the surplus water availability, and finally land suitability analysis for agriculture towards the sustainable growth. Okay, this is the this table shows the preparation of ground research plan. Okay, this is the area area for research around 71.82. This is the surplus availability I calculated. Surplus availability around 36.17. This is the area we can groundwater we can have surplus research. This is the various thematic layers I taken for the land suitability analysis for sustainable growth from groundwater potential zones, groundwater research potential, geomorphology, land cover, soil mature and runoff, rainfall, soils and soil depth and slope. So this is the percentage of area. This is the area. This is the weight assignment through Fuzzy and AHP. Okay, finally I got these are the result. I got the land suitability analysis is categorized into highly suitable, moderately suitable, marginal and not suitable. So this is the area I got. This is the this is the characters and what are these are the remarks. Okay, this is the final map. I got the land suitability analysis for agriculture. Okay, this black color shows the not suitable for agriculture, and finally this yellow color is good, highly suitable for the agriculture. Okay, summary and conclusion. Coming to morphometric studies analysis, Jilledubanderu River Basin reveals the sixth order stream, and it exhibits a dendritic drainage pattern. It implies that rocks are highly homogeneous, having uniform resistance to erosion and horizontal direction. However, the drainage pattern of the basin mainly controlled by structures and lithology. The simple geometric relation between stream number and stream order and length of the stream of the basin as determined by the Laserwijk transformation is good agreement with the observed data, such as the length of basin is more to width. Coming to bifurcation ratio and drainage density, texture ratio and relief ratio of the basin reveals the rapid runoff of the river basin, low recharge and low rainfall intensity prevailing the affecting of discharge potential of the main streams. The topography aspect and lithology of the basin is important, bearing on the hydrological characteristics of the basin. The mean bifurcation ratio indicates the drainage pattern is not much disrupted through geological structures. The circulate ratio reveals early to late mature topography due to the differences in slope, relief, and structural conditions. The elongation ratio indicates the strong relief and steep slope characterize the basin. The river basin is originates from steep slope area. The most of the streams occur in the comparatively plain lands, and the subsurface stratum is permeable. Therefore, the plains are important locations for the construction of artificial research structure for augmenting of the groundwater by the morphometric analysis. Okay, coming to runoff objective, the Jilledubanderu River Basin is basin with granitic terrain, basically shows the moderate to high runoff potential, which is reasonable for potential rainwater harvesting sites. The field studies shows that the localized potential map is accurate with 82.85% with existing structure data. So based upon the AHP decision making model like AHP procedure, I went for the artificial potential research zones and research zones and adequate research structures, and their objective to improve the groundwater conditions in the area under the consideration. About 3.1% of the area is generally recognized very good, and 42.08 is the area is designated good groundwater research area, and 53.28% and 1.5% goes separately under the moderate to poor groundwater. The suitably artificial research structures built in the study area are mainly check dams, percolation tanks, and quorum ponds with a total number 48 numbers in the study area. The overall accuracy study is around 80 to 85%, having the good agreement with the existing structural data. The remote sensing and JS and AHP procedures have shown they are very visible to adapting the suitable areas for artificial research structures for groundwater research compared to other conventional strategies. This study will be promote the appropriate improvement and development and conservation of groundwater resources in the research area. The surplus water availability calculated based upon the water's calculation according to CGWP method. The watershed is having around 71.82 MCM watershed region is there. Based upon the watershed region, I went for the research area. And total, getting the total research area, I went for I taken the 30% of the total runoff. Based upon the CGW method, I got the 36.17 MCM is the suitable for the surplus research. Okay, after that, I went for the groundwater potential zone. Shows the central regions have the greater groundwater potential zone than the eastern parts of the Jilledubanderu Basin, which is effectively support the groundwater extraction data and groundwater fluctuation maps. In addition to the sufficient results, the study is extremely valuable for groundwater planning and sustainable management and artificial research structures for the Jilledubanderu Basin on the page. The accuracies of resultant map is determined by AEC ROC curve method, having the accuracy of 72 and 76 and 78 and 82. This is the 82% is matching with the integrated method of physiology and AHP and frequency ratio. Coming to drought modeling, drought is not merely happen in the natural phenomena. It affects the every climatic and climatic zone worldwide involving the multiple sectors. Hence, it draws the attention the researchers and planners to hazard mapping and risk assessment. The villages falling in the extreme or severe drought zones express the drinking water scarcity, taking a large toll of government functionaries to provide the water to sufficient for drinking and domestic needs. These villages must be provided with the relief measures like piped water supply schemes and gravity-based water supply, spring water storage tanks, and exploring porch experts and etc. The water budget exercise village level is recommended to understand the water requirement for drinking as well as irrigation purposes according to shift from cash crop to local suitable crop and less water intensive crop to combat and scarcity. And the present study underlines the positivity of hydrological field data and especially the hilly and highly undulating granitic terrain. There is a need of establishing network of piezometers, digital water level record sensors that could be helping the characterizing the heterogeneous of granitic aquifer. Besides the considering climate variability, the high frequency of rainfall, temperature, and evaporation data also necessary to strengthen the predictability of the drought. This study brings out avenues for future research to evaluate the vulnerability involving the relevant socio-economic and ecological factors. The groundwater samples are collected around 96 two seasons like pre-monsoon, post-monsoon in the year of 2019 for the suitability analysis for the sustainability. And it indicates the groundwater chemistry is mainly influenced by the underlying lithology and there is no effect of anthropogenic as well as very less seasonal effect in the agriculture activity. The post-monsoon season majorly shows the calcium, magnesium, and bicarbonate water type, and pre-monsoon sample shows the calcium and bicarbonates. And as well as mixed calcium and sodium and bicarbonates, water type represents the granitic and granitic well as well as irrigation. It is suitable for irrigation. The irrigation suitability indices such as SAR, Ellis ratio, soluble sodium percentage, RSA and permeability index, and salinity magnesium methods are calculated taking the data from pre-monsoon and post-monsoon of two seasons. The indices indicated the groundwater is suitable for irrigation except PI in pre-monsoon, while magnesium hazard shows unsuitable in the both seasons. I taken the total 70 VS for the groundwater resistivity data in the field-based data that represent all lithologies, landforms, and geomorphological features of the study area. In the VES curve type, three-layer medium is absent due to the diverse of lithology in depth. Out of 78 curves, 60% is 80% are on 4-layer, and other remaining 3 means 4% of 3-layer curves, and 7 are 5-layer curves significantly heterogeneity in the subsurface. All the VS curves are associated with the AA type, indicates the hard rock terrain, and around 86% of VS curves. Moreover, only 3% of VS curves are associated with 3-layer hard rock. The 5-layer curves is HAK, and major HAK is major curve type. And HAK also 7 curves are there in the due to the weather section and favorable for the accumulation of groundwater. This is the dark Zork parameters are employed like to estimate the groundwater resistivity parameters. However, the greater variation in the conductance due to the conductance due to the heterogeneity of rock structure lithologies, indicating the changes in the permeability, and less conducting values indicating the mirage protective capacity of the aquifer. The transverse resistance values of Jilledubanderu River Basin diverge from the 148.7 to 6,16,120.56 ohm meter. The higher T values are associated with the zones with higher transmittivity. The low values of T observed in the central and northern part of the study area. The higher controls are the conductance transmittivity in the north and western parts of the basin. It is observed that the maximum VS location in the central and northeastern parts of the basin is suitable for the groundwater potential due to the presence of lineaments and falls and failure channels. Besides VS number 6, 8, 17, 18, 17, 19, 21, 22, and 40 are not favorable sites for the marking of groundwater potential due to the least weathered hard rock export at these locations. The study is recommended that the construction of water harvesting structures along with the VS points will be helpful to the development of groundwater resource management in the study area. The detailed lineament studies and making of failure channels, marking of failure channels in the river basin. We can use ground magnetic surveys also to helpful for the more precise in the demarcation of groundwater potential in the study area, sized for the future studies. The present study also been considered out of FAO methodology for the sustainable land suitability analysis for agriculture. It's found that only 2.98% is highly suitable for the agriculture. These lands have very gentle slope, loamy soil type, and moreover water holding capacity are also very less. About 75.98 lands are moderately suitable class. These features of these lands are steep slopes having a deep soils and the deep soils in the pediment zones. The moderate water retention capacities, soil moisture and runoff also. The area under the vegetation and very slight shrubs have also been recommended for the agriculture. However, it's need to extra effort for planning of soil and water conservation in the moderately suitable areas. The marginally suitable lands for land suitability analysis for agriculture around it got 17.35% of the total river basin. It shows the shallow soil cover and steep slope and low water holding capacities and poor soil moisture and nutrients for the soil moisture and nutrients, and it have high runoff. So the adjoining lands also used for the agriculture, but there is a need for shield from extensive soil erosion. The not suitable areas like land suitability were estimated around 3.98% in the present study. These lands have been very steep slope and rocky lands and barren lands and thin and dry soils. The agricultural lands medium to dense forests also not suggested for the LSA. The collaborative collective and integrated approaches are desperately needed for the efficiently manage the watershed. All these above factors were incorporated sustainable growth of land suitability assessment for sustainable growth potential. All above analysis were renowned degraded semi-arid and rain shadow regions to increase the capacity and effectively use of precipitation. They decrease the soil loss and increase the soil nutrients to enabling enhanced yield supplement profits and gainful watershed development plan to ensure the effective implementation and selected adoption measures. With due consideration, the address issues the environmental and social safeguards. There is a need of imperative far-sighted policy changes that acknowledge the natural resource constraints to enable the Jilledubanderu sub-basin, the poorest and most vulnerable, to benefit from efficient, clean and resilient green growth cover. The master management plan integrating social, economic and ecological and policy concerns from the entire watershed should be developed and properly manage water uses and pollutant loads of the Jilledubanderu River Basin. The results of the study is useful for the farmers, in the area to increase their income and productivity, as well as the watershed developer, managers and planners and researchers in this field. This is the adjudicators questions asked in my thesis. This is the answer. First question: how the present work is different from earlier studies mentioned in the literature. So the present study is different as compared to earlier studies like drought modeling to vegetation conditioning. I am using Python and Google Earth Engine. I use, and next to artificial research structures, objective, I will propose the various research structures like gully plug and check dams and percolation tanks. And finally, I recommended the various watershed development plan through land suitability analysis using various thematic layers with using decision-making approaches. To accuracy, I measured with the AS and ROC curves using machine learning programs. What is the difference between raster, SRTM, and Watershed diagrams? The ROS diagrams is extracted from the different data sets for a particular basin, shows the similar trend of frequency and directions, which indicates this, indicate that changing the data set does not have any substantial effect of orientation of the elements. So only the ROS diagram can help we can measure the thickness and directions of the various dams like raster and SRTM, Watershed. And next question: what is the difference? Gully plug, nulla pond, and forum pond and percolation tank. Okay, gully plugs are built using local stones, clay, and bushes across the small gullies, and the stream running down with a hilly slope, carrying a drainage to tiny catchments during the rainy season. The gully plugs help in the conservation of soil and moisture, soil conservation and moisture. The sites for gully plugs may be chosen whenever there is a local break in the slope to permit the accumulation of adequately water behind ponds. The nulla pond across the bigger streams of second order, the areas having the gentle slope. The nulla pond acts as a mini percolation tank. The forum ponds are basically small size rectangular trenches will collect the runoff water in the agriculture fields. Interconnectivity of forum ponds will not only result in effective groundwater recharge, but also dilute the contaminants in the groundwater. The duct wells will also serve as similar purposes. The percolation tanks are artificially created surface water bodies submerging land area with adequate permeability to facilitate the sufficient percolation of important surface runoff to recharge of the groundwater. Next question: what is the difference between identification of artificial groundwater research structures and groundwater watershed? Artificial groundwater research structures are made to increase the potential of groundwater to construction structures like check dams, nulla ponds, and gully plugs, percolation tanks, and injection wells and gravity wells also. Potential zones, we have the potential zones where we can get the water for domestic irrigation, drinking, and industrial purposes. What is the region of very hot water in the post-monsoon season? The calcium and magnesium import the hardness to the rock and bond due to the weathering process, which leads to dissolution of minerals from the parent rock. The bicarbonates, on the other hand, are dominated due to the weathering of carbonates and dissolution of silicate minerals. The higher values also indicate the anthropogenic activities. Okay, this is my publications. Okay. This is a national publication. So this is my co-author publications. So this is the paper presently it is under review. This is the seminars I attended in international and national. This is the training courses I attended the international and national also. This is the programs I used for the calculation of standard precipitation index. Like I explained in the metrological drought. Okay, this is the program I write. This is the result I got. This is the program I written in the estimation in the vegetational conditions through drought modeling and vegetational condition index. This program I written in Google Earth Engine. This is the result I got. I received the best research award for my research study, Vice Chancellor of University in the occasion of National Science Day. Recently, my region also received the funding to construction of artificial research surplus. I received the funding also. This is agronomics. I wish to record my sincere thanks to Propan Sensor Respect and gratitude of my guide, Dr. Chris Version of the Associate Professor, Department of Geology. The words proved to be insufficient to express the continuous support and motivation towards my study period. I would like to give special appreciation to Dr. B. Raghav sir, Dr. M. Jayara sir, and Dr. B. Smita madam, Dr. S. Srivastava sir. They constantly ensure the availability of all the required resources for the completion of the thesis. Additionally, they have always provided me with the much needed motivation and reinforcement to enable me to finish this work. I am also grateful to University Grant Commission to providing NFSC fellowship or financial support of this research. I am greatly grateful to Vijay Bhagat, Vasant Bhagat, and Bhavana Umbrikar ma'am to valuable perspective and insight during my presentation, their suggestion and contribution. I would like to express my deepest gratitude to Dr. G. Srinivasu, Dr. Ajay Kumar Kadam, to contributing more than me to putting my together to completion of this thesis. Their valuable suggestions and cooperation at various level of my work has been major factor towards the work. I am also thankful to Mr. B. Upendra for extent answers to providing the facility during my water analysis, which has been highlighted. I am also thankful to Dr. P.D. Sridevi Madam and MJRI providing for training and geophysical restrictive interpretation during the geophysical studies, which has been highlighted in this course. I would also like to especially to Mr. Appreciate Professor Pradeep Kumar, Dr. Jamil, I'm also thankful to my co-research scholars, Vice Version Reddy, Dr. B. Suvarna, C. Pawat, and Ravi Kumar for being support and encouragement at every stage of my thesis. And also all cooperation, for all cooperation, I have question from them. I'm also thankful to my student scholar, Dr. Siddharaj, for his assistance and help the constituency provided whenever needed. I'm also thankful to my students for assistance and help constantly provided whenever needed in my field work. I'm also thankful to everyone I have inadvertently and unintentionally missed out on this acknowledgement, but we have contributed any little way in building the shape of this work through words, gestures, and business and otherwise. Thank you.
Raju garu,
Sir,
the presentation appears to be good.
sir, thank you, sir, thank you.
I have a few small queries.
Sir, okay, sir, okay, ask.
These only 4 queries, very simple queries.
Okay, sir, okay. Ask.
And presentation is excellent, and this is fit for getting the PhD degree. And I really congratulate the student and guide for choosing a novel topic.
Thank you, sir, thank you.
If you take the land cover, land usage, or water, or the rainfall, you use mostly the satellite based derived products. Am I right?
Yes, sir.
Babu?
Yes, sir. Yes, sir.
Babu. So then what is the accuracy of each satellite? That is missing. Actually, his research is revolving around the accuracies. If the accuracy is, say, for example, plus or minus 1 meter or 1 kilometer, the accuracy changes a lot. The spatial separation and the temporal resolutions are the paramount interest and important for the entire research.
Yes, sir.
Am I right, Babu? Then with
Yes, sir.
can you throw light on it?
Yes, sir.
Yeah,
Sir, I taken the various satellite images like Landsat, Landsat 7 and Landsat 8. It have 30 meter resolution. 30 meter resolution. And after I'm getting that satellite imagery.
Resolution accepted. No, win. Is accepted. Again, the revisiting of the place by the same satellite will take how many days or how many months or how many years? I don't know exactly.
Sir, there is a 7 days. 7 days is there, and 32 days is there, and 16 days are there, sir.
Yes, because of the inequality of the Earth. That is right. Yes, so then your samples has the skewness, because if it is revisiting 7 days by 7 days, then there is no skewness. If it is visiting 7 days, 13 days, or 15 days, then you are missing the information by weekly diurnal variation or weekly seasonal variation is missing.
Sir, I taken 16 days, every 16 days, sir. For estimation.
For that in a model, there is a correction, ma.
Okay,
Did
okay,
you applied that model, or you have taken the raw data itself and you worked on the images?
So I taken the raw data and I processed in the software, sir.
Very good. What is that software, Nana?
RGA software, sir.
Very good, Nana. Excellent.
Yes.
Okay, Nana, and I wish you for many more good research activity. And this is the beginning for you after getting the PhD. Please continue in the PhD and hoping that you may be successful as a good researcher elsewhere on the globe in your future endeavors. Thanking you, and
Okay, thank you.
also Dr. Sudarshan Raju.
Thank you, sir.
Any suggestion, any doubt? Please ask. Sir. Sir. Sir.
Sir,
Sir. Not audible.
sir, your voice is not audible, sir.
Not
Clear.
Hello.
Sir,
It is audible.
yes, sir.
audible, sir.
Audible or not?
Audible, sir. Audible, sir. Your voice is audible, sir.
Yeah. Sir is asked that waterfall depends on the waterfall you have got it from the satellite images. That is not true. That's what I said. Right?
Sir.
Waterfall data it is taken from the satellite image. That is from the collection of the data from the various stations, right?
Yes.
Sir, your voice is not audible.
Not yet. Not yet.
Hello.
Sir.
Is it okay now?
Okay, sir.
The question that asked by the adjudicator, the earlier question that you have got the data from the land use, land cover data and waterfall data from the satellite images. But
Yes,
you
sir.
said, okay, the waterfall data you have not got from the satellite image, but you have collected from the rain gas station, right?
No, sir. Sir asked about land use land cover preparation.
Apart from that, sir also asked about the waterfall data also.
No,
So,
sir.
yeah,
Water quality collected samples, sir. By
yeah,
field
that,
study.
that too, sir. One more thing that the whatever the temporal variations, that doesn't matter in the collection of the data for you,
Yes, sir.
because even 1 year or 2 years data to you take the land use land cover you can do it.
Yes, sir. Yes, sir.
Land use land cover this thing that you need not have the temporal data, right?
Yes, sir.
So every 16 days you have not collected the data, right?
No, sir. Only for particular year only taken for land cover only, sir.
That land cover also for
Yes,
every
sir.
16 days you have not taken the temporal data.
No, sir. Every not in agriculture, whenever agriculture grows, that months only I taken, sir.
That question, that answer you should have given to the sir,
Yes, sir.
the earlier questionnaire. Okay.
Okay, sir.
Okay. Anyway, that your work is laudable, and it is one of the best pieces that I have evaluated so far. And I congratulate you and also your guide, Professor Raj Garu.
Thank you, sir.
Thank you. Okay, Raj Garu, I take leave of you then. Please.
Krishna Reddy, sir. Krishna Reddy, sir. And the సార్ యాక్చువల్ గా మనకి ఏంటంటే డిపార్ట్మెంట్ తో అంత ఇంటరాక్షన్ లేదు సార్. వాళ్ళు మనం వెళ్ళినప్పుడు వాళ్ళు ప్రొవైడ్ చేయలేకపోయారు. కొన్ని ఇయర్స్ మాత్రమే ఇచ్చారు నాకు అన్ని గ్రౌండ్ డిపార్ట్మెంట్ వాళ్ళే నాకు ఇచ్చిన వాటర్ లెవెల్స్ బేస్ చేసుకొని ఒక పర్టికులర్ 5-6 ఇయర్స్ చేశాను సార్. చేశాను సార్, చేశాను. పేపర్ పబ్లిష్ అయింది.
Raju garu, can I leave or can I be on the line? Sudarshan Raju. Can I sign off? ఏమండి I am signing off. I will please bring the official documents. I will sign after 2 p.m. Okay, Andy, please. Thank you.
Thank you.